Hello, welcome to this video on reviewing Chapter 7, a bunch of trig stuff. What I'm going to do, give you a quick overview here. I'll go through a couple problems where you'll be given a side ratio and you'll have to find another trig ratio. Do a couple of those, some simplifying expressions using identities, a few verifying identity problems, some of the sum or difference formula ones. I got one that's in radians, so we'll convert that to degrees and solve it. And then another one of those sum problems where you'll be given side ratios and have to use a Pythagorean theorem and find some values. And then we'll just finish with solving some trig equations. And that'll be all of it. Alright, so I'll start with these first problems, which I'm going to give you a side ratio. So I'm giving you if sine x equals 5 over 13, find cotangent. And the directions say we're going to assume that all angles are in quadrant 1. So what I'm going to do is just sketch a triangle here, don't care how big it is. And what I'm going to do is label this angle as x. So we are given that the sine of x, so the ratio of opposite over hypotenuse is 5 over 13, because that's what sine is. And what I'm going to do is find the cotangent. So I know that tangent is opposite over adjacent, so that means that cotangent is going to be adjacent over opposite. Problem is, I don't know my adjacent side. So we need to figure this out first with the Pythagorean theorem. I'm just going to define some random variable here. I'm going to just call this y. I'm going to say y squared plus 5 squared equals 13 squared. And then, again, simplify this just using the Pythagorean theorem. So y is going to end up being 12. So what I'm going to do is just replace that or substitute that right here. And then again, at the very end of this, we're finding cotangent. So all that you're going to do is take the adjacent side, which is the 12, over my opposite side, which is 5, and that is my answer. Same thing for this problem. I'm going to give you secant. Secant is going to be your little flippity-flop of cosine. It's a reciprocal of cosine. So because I know that cosine is adjacent over hypotenuse, I know that secant is going to be my hypotenuse over my adjacent side. So again, I'm going to make a really just rough sketch of a triangle here in the first quadrant, and you're going to label your adjacent side as the 3, and your hypotenuse is 5. And same thing as we did in the last problem is use the Pythagorean theorem here. 3 squared plus some number squared is 5 squared. That sum number, I'm going to save a little time here, that sum number is going to come out to 4. Okay, so 3 squared plus 4 squared will give us 5 squared. What we want to do again is figure out the sine ratio of this, which again, sine is going to be your opposite over hypotenuse. So I'm going to take my opposite, which is my 4, over my hypotenuse, which is 5. And all we're doing is solving for the ratios. There are shorter problems like these. If I would have given you secant as 5 over 3 and asked you for cosine of x, well, as long as you know that secant and cosine are reciprocal functions, you don't have to do really any math except flip that fraction. So that's another type of problem that you may see, which again just kind of tests your knowledge on knowing that these are reciprocal functions. With these ones now, these are going to be kind of crazy. We're going to simplify some of these expressions using trig identities. So what I like to do is follow a couple of rules here, which would be really to get stuff in terms of sine and cosine. What I mean by that is, okay, I know that I have a couple identities for tangent, and there is one that could get it in terms of sine and cosine. I also want to look out for Pythagorean identities, which is anything that would say like, oh, 1 plus tangent squared x, and that's going to be a trig identity. That would be a Pythagorean identity. So that would actually simplify to secant squared x. Cosine squared x plus sine squared x is 1. So again, there's a couple things you have to look out for that are Pythagorean identities, but outside of that, I would really just try to simplify your secants and your tangents and cosecants and just get them in terms of sine and cosine, and then simplify from there. So what I'm going to do in this expression is bring my numerator over. I'm going to rewrite my cosine squared of x as being over 1, and I'm going to rewrite tan squared x as being sine squared x over cosine squared x. And that's the reason why I rewrote the cosine part over 1, is now you can see that, hey, this one's on the numerator, this one's on the denominator. I'm going to simplify this expression by bringing over my numerator, which is 1, and my denominator is, I'm simply left with 1 over, sine squared x. So from here then, again, that is another identity that this is a reciprocal, and 1 over sine is cosecant. So since it's squared, this would be cosecant squared x. Bam. All right. Next one. This one looks really ugly as well. Again, my advice to you right away is take this cotangent, take this secant, and get them in terms of sine and cosine. So again, I'm going to take this sine to the third x, and I'm going to just write it over 1. I'm going to take my cotangent, and again, I'm going to put this in terms of sines and cosines. I'm going to take my secant, same thing, that is a reciprocal function for cosine, and then I'm going to bring over basically this part, the cosine squared of x. This is a lot of writing, and I think this is just going to come out to 1 if I'm not mistaken. So how this is going to work then, you got cosine on the denominator, cosine on the numerator, they're going to go away. I have a sine on the denominator, and I have a sine to the third up here. This is going to cancel, and then this is just going to change to a 2. So I'm going to be left with, after this entire thing is simplified, I'm really just going to be left with sine squared of x, because it's really times 1 divided by 1. So that's going to be sine squared of x, and then I'm going to bring down the cosine squared of x. And again, this is a Pythagorean identity. Sine squared x plus cosine squared of x is 1. So that entire ugly trig expression is just going to really simplify to 1. And these ones then, so I'm going to kind of like piggyback off these ones. Notice these are expressions because they don't have equal signs. These are equations, and what you're doing is you're verifying the equation. Again, my advice for you on this one would be just leave the side that has less stuff, just kind of be there, and simplify the side that has more stuff. So I'm going to do this the same way. I don't see any trig identity or Pythagorean identities just popping up. So I'm going to simplify my cosecant first. So I'm going to rewrite sine x as sine x over 1. I'm going to rewrite cosine x as cosine x over 1. And I'm going to rewrite cosecant x is 1 over sine x. And again, you're just going to bring the right hand side down without touching it. And all we're doing here is verifying this. So the whole idea is that I can just leave this right side kind of be, and I'm going to simplify this by taking this sign that's on the numerator and the sign that's on the denominator, crossing those out, and really all you are left with on the left hand side of this equation is cosine x, and that's what you had on the right hand side. Once you verify what's on the left is equal to what's on the right, you put the little check mark there, and that says, hey, I verified this identity. Alright, next one. Same thing with this. What I would recommend, even though I have like a plus sign here, I don't see like a cosine squared plus 1 or a 1 minus something squared. So I cannot use a Pythagorean identity right off the bat. What I will do is rewrite this as just cosine x plus sine x over cosine x. So I'm replacing again or substituting my tangent identity as sine over cosine. I'm going to rewrite my sine x over 1 again and bring down the secant x. So like I said, work on the side that has more stuff. Now, it would be a very, 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 very big mistake if you crossed off these signs. So that is why I express them, or I express this as sine x over 1, is so that you don't make that mistake. Instead, what we really have is cosine x plus, and then this is multiplying a number times itself. Sine x times sine x is sine squared x. And bring down the cosine on the denominator, and then bring down the secant x part. So on the left-hand side of this, what I'm going to have to do is find a common denominator, because technically my cosine is over 1. So if I were to find a common denominator here, I could just write it as cosine x. So basically, this cosine is already here, so I can just bring my sine squared x down. If I were to turn this 1 into cosine x, I would need to multiply it by cosine x. What I do to the denominator, because we're finding a common denominator, whatever I do to the denominator, I have to do to the numerator. So if I multiply this denominator by cosine, and I multiplied cosine by cosine, it would square it. And I would really end up with this. So really this whole, I guess the difficulty here is just finding that common denominator, which in this case, like I said, it would be cosine. And now I see that I have a Pythagorean identity. Sine squared x plus cosine squared of x is 1. So what I really have on my numerator is 1 My denominator is cosine x. Again, I'm just going to bring down that right-hand side. And then this is an identity. It's a reciprocal identity that 1 over cosine is secant. So again, verified it. Excuse me. So again, with the difficulty in this problem, I would really say it's just finding that common denominator is kind of a pain. In the last problem that we did, it was really easy just because certain stuff canceled out. And in this one, it's going to be another problem where we will not have to find a common denominator, but it has to just jump out at you that I have a Pythagorean identity. It would really upset me if you just did this. Okay, cannot do that because the cotangent x squared part is not a factor. Again, we have this addition here. You cannot just cross those off and just bring a 1 over. And that wouldn't make sense because then you would end up with 1 equals secant squared of x, and that's just not true. So what I am going to do is look at my little formula sheet of which Pythagorean identity this is, and cotangent squared x plus 1 is cosecant squared of x. And then I'm going to bring down my denominator. So again, I'm working off the side that has more stuff. What I'm going to do is rewrite my cosecant and my cotangent in terms of sine and cosine. So like I said, that's where I'm going to just write these as two fractions. My cosecant squared of x can be simplified to 1 over sine squared of x. And my cotangent can be expressed as cosine squared of x over sine squared x. And again, bringing down the right-hand side of this equation, not touching it. Which sometimes if there's more complex stuff on this right-hand side, you might have to simplify both sides before that you can see that the left-hand side matches the right-hand side. With this problem, this is going to simplify nicely too, and we'll see where the secant comes from. My next step here, I'm going to just rewrite this. This denominator is going to slide to this denominator, and this one here is going to move up and multiply to my numerator. Okay, it's just a little fraction trick. Okay, so off to the side, I'm going to just give you an example of my little fraction trick. If I were to have 3 over 5 over 2 over 6, and I said, okay, multiply this, or I'm sorry, divide it, you would multiply by the reciprocal. And what really happens is the 5 would multiply by the 2, and the 6 multiplies by the 3. So this same logic with fractions is what I'm going to apply here to this trig example. And again, it's just going to simplify some stuff that's going to cancel out. So what I'm going to really have then on my numerator is sine squared of x, and then times 1. And then my denominator, I'm going to have the sine squared x, cosine squared x. And then still bringing down the right-hand side, not touching it. What I'm left with here then, my sines will cancel now. And I'm left with a 1 on the numerator. So what I really have is 1 over cosine squared of x. And then again, this is a reciprocal identity. 1 over cosine squared x is secant squared of x. So my left-hand side does match my right. Alright, moving on. Sum or difference formulas. So more formulas again. What you want to do for these is have your unit circle out. And what you want to do is break apart 165 degrees into either the sum or difference of two angles that are on your unit circle. So I am going to break apart cosine 165 into the sum of two angles. I'm going to use 135 plus 30. So again, 135 and 30 are both on my unit circle, and they add up to 165. So the cosine formula for this says what I'm going to do, and I'm going to break this up, and I'm going to call this x, and I'm going to call this y. The cosine formula says if I have cosine of x plus y, I need to first take the cosine x times the cosine of y. And this formula is weird. Because this is a sum, you're going to put a minus here, and then put sine x sine y. So that is part of the formula for this. If I would have used a difference here, I would have had a minus, then this would change to a plus. And that again is just part of the formula for this. So I'm going to replace my x's and y's with my 135 and my 30. So I'm going to do cosine of 135. Oops, let's rewrite this. I'm going to write this as cosine 135 times the cosine of 30 minus sine 135 sine 30. And now you're just going to get these values from your unit circle. Again, every coordinate on your unit circle Your x part of the coordinate would represent your cosine part, the y part would be sine, and if you wanted to find tangent, you'd have to take your sine over cosine, which is an identity, and that means you would take your y value over your x value. So what I'm going to do is go on my unit circle, find where 135 degrees is, and again, I'm going to take the cosine part, which is the x part of this, which is negative radical 2 over 2. And then the cosine of 30 is going to be radical 3 over 2. Sine of 135, so taking the y coordinate, which is radical 2 over 2, and the sine of 30 is 1/2. So again, I'm just reading the y parts of my coordinates on the unit circle for these values, and then for the cosine ones, I'm reading the x's. So this is going to simplify pretty nice. Negative radical 2 times radical 3 is negative radical 6. My denominator, 2 times 2 is 4. And then I'm going to put my minus. Radical 2 times 1 is radical 2, and then again, denominator is going to come out to 4. So these are nice because I can express this as, I already have a common denominator, so I can express it as a single fraction just over 4. So just bring your denominator down and bring this as negative radical 6 minus radical 2. So that is your answer. And again, you cannot simplify this more. So don't try to subtract the insides of these radicals. You cannot do that. So just stop there. You're done with that problem. If you wanted to verify your answer, what you could do is just type in negative radical 6 minus radical 2. I would hit enter and then divide by 4 in your calculator and get the decimal equivalent of this. And then if your calculator is set to degree mode, you can just type in cosine 165 and you'd get the same answer. Okay, so again, the cosine 165 is going to give you a ridiculously ugly irrational decimal. And that's why what we did is we found the rational version of that. Alright, next one has to do with radian measure. Basically, I'm going to just take my 7 pi over 12, convert this into degrees by multiplying by 180 over pi. So this is something we had done in the last unit where you can convert from degrees to radians, radians to degrees. All that I'm basically going to do here is just notice that my pi's are going to cancel out. One in the numerator, one in the denominator. So I'm going to just take 7 times 180 and then divide that by 12. And all that's going to do is give me the degree equivalent of this. So what I'm really doing is just finding tangent of 105 degrees. And now again, I want to either express this as the sum or difference of two unit circle values. And I can break this up into tan of, and I'll do 60 plus 45. Okay, so again, 60 is on my unit circle, 45 is on my unit circle. They will add up to 105. So my tangent formula, again, I'm going to label this with having x's and y's. And it would not matter if you were to flip these numbers and write it as 45 plus 60. But my tangent formula says, okay, if I use tangent of x plus y, I'm going to simplify this to tan x plus tan y over 1. And then this is where you got to be careful. It'd be 1 minus tan x tan y. So that's the same thing how that cosine formula worked in the last problem where we had a sum here and then we had a difference here. Same thing. If I were to subtract with tangent and have a minus here, the numerator would also have a minus, but your denominator would have a plus. And again, that's just all part of the formula for this, which again, you'd be given. So what I'm going to do now is find these values on my unit circle, which again, tangent, I'm going to go back to when I said this here. Tangent is where you're going to take your sine over your cosine. So you're going to take your y values over your x values. Okay, so what I'm going to do is replace these values first with my 60 and 45. Tan 60 plus tan 45 all over 1 minus tan 60 times tan 45. So what's nice is once you get the two unit circle values for the top, they're the same ones that are on the bottom. So again, what I would do is go to the unit circle and you're going to find where 60 degrees is, and you're going to take the y coordinate, which is radical 3 over 2, over the x coordinate, which is a half, and really that's just going to simplify to radical 3. So the tangent of 60 is radical 3 plus, and then tan 45 is radical 2 over 2 over radical 2 over 2, which is some number divided by itself. So that's just going to simplify to 1. So tan 45 is 1. And then my denominator, I'm going to have 1 minus, and then radical 3 times 1. So this final expression, I'll just simplify it and write it as 1 plus radical 3 over 1 minus radical 3. And you can just leave your answer like that. So again, that's the tangent one. And that one was a little bit different because we had to first convert it into degrees. And then lastly, with these ones, I'm giving you the ratios. So again, I'm going to just sketch 2 right triangles here. And we're just going to label the side ratios of these things. Given that, again, I'm going to be given, in this case, the sine of one and a cosine of another. So sine of x, so I'm going to call this x, and my sine is 8 over 17. So that's opposite over hypotenuse, so 8 over 17. And then for the y one, tangent of y, so I'm going to call this y, and that's going to be 3 over 5. So that's my adjacent over my hypotenuse. So again, I'm going to save kind of a minute here. Again, Pythagorean theorem, you would set it up as some number squared plus 8 squared equals 17 squared, and that number is going to come out to 15. And then same thing here, 3 squared plus 4 squared would give me 5 squared. So I'm just using the Pythagorean theorem there to get the 15 and the 4. And now I'm going to go back and use this cosine formula. Again, it's the sum of 2 numbers. So cosine of x plus y is going to simplify to cosine x cosine y minus sine x sine y. And again, that's part of the formula that if this would have said minus, you would have changed this to a plus. So now you're going to, instead of using unit circle values, we're going to use our ratios. So cosine of x and cosine of y means what we're going to do is look at the adjacent to hypotenuse ratio of x and y. So the first one, your cosine of this would be 15 over 17. My cosine of the y is 3 over 5. And then for the sine values, you take your opposite over hypotenuse, and then same thing here. So again, that's why it was necessary first to do the Pythagorean theorem, is to get the 15 and 4 because we needed those values. So now I'm just going to multiply straight across the numerator and denominator. 15 times 3 is 45, 17 times 5 is 85, bring over my minus, 8 times 4 is 32, and then again, same denominator is 85. So this is going to simplify nicely. So just subtract your numerator. So 13 over 85. All right, so those are the sum and difference identities. And then we're going to finish this video with solving equations then. So with these principal values, go through really briefly, for sine and tangent. Okay, so for sine and tangent, it's going to be your first and fourth quadrant would be your principal values. And then cosine is going to be your first and second quadrant. Okay, so we're going to solve these for what are called principal values, which means when you're looking at the unit circle, if it's a sine problem like this one, you're only going to look at the answers for quadrants 1 and 4, and if it's cosine, you're only going to look at quadrants 1 and 2. All right, so what I'm going to do here first to solve this equation is divide both sides by -2, and I'm going to get sine x equals negative over negative, so positive 1/2. And all that you're going to do is go on the unit circle, and again, every coordinate is cosine sine. So I'm going to look at where my sine value is 1/2 and just give me that angle measure, and that is 30 degrees, which you could also express as pi over 6 radians, same exact thing. And that's all you're going to give me is that one value, because I know that sine is 1/2 at 150 degrees as well, but 150 degrees is in the second quadrant, and that's not a principal value for sine. So just 30 would be your answer here. With this one, we're going to simplify this first and then do some factoring. So this is a little tough first. 1 minus sine squared of x is an identity. Okay, so just take that in for a sec. 1 minus sine squared x is a Pythagorean identity, and it is an identity for cosine squared of x. Bring down the rest of this equation. Okay, and what I'm going to do here is factor. Okay, so I want to look at what goes into both of these things that I can divide out. So I'm going to actually divide out cosine x in both of these expressions. Okay, so cosine squared of x divided by cosine x is cosine x. And then cosine divided by cosine is going to give me 1. Okay, So what I'm going to do here then is take each of my expressions that I factored out and set them each equal to 0 because the right hand side was 0. So cosine x equals 0 and cosine x plus 1 equals 0. And again, we're still solving these for principal values. So what you want to do is look at where your x coordinate, because we're talking about cosine now, so look at where the x coordinate is 0, and that's going to occur at 90 degrees. Okay, and then with this one, I'm going to subtract the 1, and I'm going to look at where my x value is negative 1, and that is at 180 degrees. So both of these answers would satisfy this equation. Again, you could take these numbers and substitute them back in here, and you would end up with 0 then at the very end. Now for these ones, it says for all angles from 0 to 360. You might also see that written as 0 is less than or equal to x is less than or equal to 2 pi. Same thing, or if I say 0 is less than or equal to x is less than or equal to 360. All it's saying is you're going to use your entire unit circle here, and anywhere that you see that value, you're going to give me those numbers. So again, if I were to go back to this first problem, again, my principal value is 30. But if I said look at the entire unit circle where your y coordinate is 1/2, you would also have had 150 degrees. And that's the only difference with these types of problems. With tangent, it's kind of a little bit more of a pain because again, tangent is not just on your unit circle. You have to take your y values divided by your x values. So negative 3 over 3, negative 1. So what you want to do on your unit circle is find where you can take your y value over your x value and it would come out to negative 1. So that's not going to work at any of the quadrantals. So don't try to say right here that 1 divided by 0 is negative 1 or that negative 1 divided by 0 is negative 1. Those are not going to work. Those are undefined. And then same thing for your x values. You cannot say that 0 divided by 1 is going to give you negative 1 or vice versa. Those are going to come out to 0. So it's not going to be a quadrantal. What it is going to come out to is one of your values that looks like 45 degrees, where you're going to end up with the radical 2 over 2 part of a coordinate. Because when you take some number divided by itself, you get 1. Here's the thing. If these are both positive, tangent comes out positive. If these are both negatives, you would have a negative over a negative, and that's positive. So what I'm going to look for is where one of my coordinates would have a negative x value and a positive y value, and that looks like the one that's going to occur at 135 degrees. And I'm also going to look at the one where the x value is positive, but my y value is negative, and that's going to occur at 315 degrees on the unit circle. So again, the tangent one's a little bit more of a pain just in a sense that you have to take your y values over your x values in order to find those angle measures. And then, last problem, perfect. So what I'm going to do for this is divide both sides by 2 first. Okay, and then I'm going to write this as cosine x tan x equals negative radical 2 over 2. And what I'm going to do is use an identity here. Okay, so tangent x I can rewrite as sine over cosine. Okay, and if I really wanted to, I could write that cosine over 1 as well. So in this case, the cosines are going to cancel, and I'm going to be left with sine x equals negative radical 2 over 2, which again, you're going to give me the two values where your y coordinate, because sine is y, so give me the two values on the unit circle where your y value is negative radical 2 over 2. And that's going to occur at 225 degrees, and it's going to occur at 315 degrees. Okay, so again, with those, if I ask you for radians, those are on your unit circle as well. 225 degrees is 5 pi over 4. 315 is 7 pi over 4. So you could get those values in radians as well. I'm going to go through and quickly recap all this stuff that we did. Again, went through some of these, determined the values given one ratio, and we just found the triangle and the other ratios basically. These were simplifying expressions using identities. These were verifying, which is where we tried to simplify the uglier side first. And then we went into these ones with sum or difference formulas, and then we did the sum and difference with the ratios. And then we ended up with the solving trig equations for principal values, and then for all values from 0 to 360.